Let us work out a very simple example. We have an object which has a mass m1. This is object number 1. And m1 is 5 kilograms. And here, attached to it, is an object 2. And m2 equals 15 kilograms. There is a force. And the force is coming in from this direction. This is the force. And the magnitude of the force is 20 newtons. What is the acceleration of this system? F equals ma. Clearly, the mass is the sum of the two. This force acts on both. So we get m1 plus m2 times a. This is 20. This is 20. So a equals 1 meters per second squared in the same direction as F. So the whole system is being accelerated with 1 meters per second squared. Now watch me closely. Now I single out this object. Here it is. Object number 2. Object number 1, while this acceleration takes place, must be pushing on object number 2, otherwise object number 2 could never be accelerated. I call that force F1, 2, the force that 1 exerts on 2. I know that number 2 has an acceleration of 1. That's a given already. So here comes F equals ma. F1, 2 equals m2 times a. We know a is 1. We know m2 is 15. So we see that the magnitude of the force 1, 2 is 15 newtons. This force is 15. Now I'm going to isolate number 1 out. Here is number 1. Number 1 experiences this force F, which was the 20, and it must experience a contact force from number 2. Somehow number 2 must be pushing on number 1, if 1 is pushing on number 2. And I call that force F21. I know that number 1 is being accelerated. And I know the magnitude. It's 1 meter per second square. That's non-negotiable. And so we have that F, this one, plus F21 must be m1 times a. This is 1. This is 5. This is 20. And so this one, you can already see, is minus 15. F21 is in this direction, and the magnitude is exactly the same as F12. So you see, 1 is pushing on 2 with 50 newtons in this direction, 2 is pushing back on 1 with 50 newtons, and the whole system is being accelerated with 1 meter per second squared. Now in these two examples, the one whereby I had the baseball on my hand, you saw that it was consistent with the third law. In this example, you also see that it's consistent with the third law. The contact force from one on the other is the same as from the other on one, but in opposite signs. Is this a proof? No. Can the third law be proven? No. Do we believe in it? Yes. Why do we believe in it? Because all measurements, all experiment within the uncertainties are consistent with the third law.